Welcome back to Advent of Code 2023. We're on to day 4. Alright, so yesterday was a good day, I think. It was a tricky problem for a first 5-day problem. But I think I handled it well. Let's have a look at 4 then. Scratch cards. Okay. The gun. Let's zoom in a bit for the benefit of anyone on mobile. The gondola takes you up. Strangely though, the ground doesn't seem to be coming with you. You're not climbing a mountain. As the circle of Snow Island recedes below you, an entire new landmass suddenly appears above you. The gondola carries you to the surface of the new island and lurches into the station. As you exit the gondola, the first thing you notice is that the air here is much warmer than it was in Snow Island. It's also quite humid. This is like Minecraft, we're just crossing a biome and then suddenly you're in a tropical island. Also quite humid. Is this where the water source is? Probably not. Hello, DJ. Probably not, because we've got like 20 days left. The next thing you notice is an elf sitting on the floor across the station in what seems to be a pile of colourful square cards. Oh, goody. Oh, hello. The elf excitedly runs over to you. How may I be of service? You ask about water sources. I'm not sure. I just operate the gondola lift. That does sound like something we'd have, though. This is Island after all. I bet the gardener would know. He's on a different island, though. Small kind surrounded by water, not the floating kind. We really need to come up with a better naming scheme. Tell you what, if you help me with something quick, I'll let you borrow my boat, and you can go visit the gardener. I've got all these scratch cards as a gift. It's Wikipedia on scratch cards. Okay. The elf leads you over to a pile of colourful cards. There you discover dozens of scratch cards, all with their opaque covering already scratched off. Picking one up, it looks like each card has 2 lists of numbers separated by a vertical bar. A list of winning numbers, and then a list of numbers you have. Okay. You organize the information into a table. As far as the elf has been able to figure out, you have to figure out which of the numbers you have appear in the list of winning numbers. Okay. The first match makes the card worth 1 point, and each match after the first doubles the point value of that card. What? Oh, okay. Fine. So it's like 2 to the power of however many matches you have. So, yeah, okay, I get it. I don't need to read the example. So the elf's pile of scratchful cards is worth 13 points, so it's 2, 2, 1, 0, 0. Well, it's 2 to the power of number of matches minus 1. Because there's 1 match, you want 2 to the power of 0, which is 1. Essentially. Yeah. Okay, this is easy, I think. Let's open up PyCharm. The trick is really just, I mean, most of the work is spent just parsing it. I mean, that's not hard to parse. We do need to just... Well, we'll have a look at... I forget how split works when there's two spaces in a row. Okay, so... let's copy in our input. So we've got 197 cards. They're numbered, so I think part 2 is gonna somehow use the numbering, I don't know. Alright, so as always we want these couple of lines. So for part 1 we don't need to store anything, we just need to process. So we want to say, let's say points equals 0 and for line and f read lines. Okay, so now it's the parsing. So let me just look at what this looks like. Line dot strip dot split. That's exactly what I want, yeah. Okay. So okay, so let's say row equals line dot strip dot split. Let's say 0, 1. So 2 onwards. So that ignores the card and the 197. Alright, and then let's say I equals row dot index. So find where the vertical line bar is. So win set is going to be a set of row up to I. Okay. And then my set equals row I plus 1 onwards. Is that right? We're using strings instead of ints. But it doesn't matter because we're just looking for matches, so we can stick with string. So num matches equals it's the intersection, so it'd be win set what's intersection again? It's and so if num matches is non-zero, then points plus equals, so it's going to be 2 to the power of num matches minus 1. Print points. So we want the length of that intersection. Is ampersand the right operator here? 21959. That's, yeah, sounds like it could be. Correct. Nice and easy. Alright, part 2. Just as you're about to report your findings to the elf, one of you realizes that the rules have actually been printed on the back of every card this whole time. There's no such thing as points. Instead, scratch cards only cause you to win more scratch cards equal to the number of winning numbers you have. Specifically, you win copies of the scratch cards below the winning card equal to the number of matches. So if card 10 were to have 5 matching numbers, you would win 1 copy of 11, 12, 13, 14, and 15. Fine. Copies of scratch cards are scored like normal scratch cards and have the same card number as the card they copied. So if you win a copy of card 10 and it has 5 matching numbers, it would then win a copy of the same cards that the original card 10 won. Let's have a look at this example then. Card 1 has 4 matching numbers, so you win 1 copy each of the next 4 cards, 2, 3, 4, and 5. So you don't get any points. Alright, let's continue reading. Original card 2 has 2 matching numbers, so you win 1 copy each of cards 3 and 4. Fine. A copy of... So, okay, we need to store these cards in the list, but we only need to store the number of matches, essentially, which is literally just an int. So it's going to be a hash table, essentially. Not even a hash table, just a list of ints. Okay. Alright, so you win 1 copy of 3 and 4. Your copy of card 2 also wins 1 copy of 3 and 4. Fine. Alright, I get it. I'm just wondering if it's all... If I do this the naive way, will it actually finish in time? Yeah, as long as we don't actually do each of these bullet points one by one. So, if I've got... Well, no, I mean, you just have to collate them together. So look, your 14 instances of card 5. Or your 8 instances of card 4. So you win 8 copies of card 5. If you did this the slow way, you'd do 1 instance of card 4. That gets you 1 copy of card 5. Then you do the next instance of card 4, and that gets you another copy of 5. And so on, and that would take forever. But because the example they've given here is already actually doing that, so that's they're hinting at how to do this efficiently. So should be fine, man. It's a linear time. Technically quadratic time, but number of matches. No, linear in the number of... It's linear in the number of cards multiplied the number of integers in one card. So basically linear. Alright, well anyway. Including the original set of scratch cards, how many total scratch cards do you end up with? Alright, so we're just keeping track of okay, fine. I can do this. Don't see any issues. It's only 197 cards as well. Alright, so part 2. Alright, so we want... Hang on, let me think. So we just want one array called num cards, and that's going to keep track of how many of each card we own. So initially it's going to be 1 for all cards, right? All right, let's just process the input. So let's say cards. We're going to put all the cards in this list. But we're not going to store anything other than the number of matches. Because that's all the information we need. So part 1 is just that. And now we just want to deal with use cards. All right, so we've got our cards. Let's have a look at cards. And this is just number of matches. There's a few zeros as well. Okay. Alright, and we want an array which is going to be num cards equals, let's say 1 for so basically a 1 for every card. That means we've got 1 of each card. Alright. Okay, so then what we do is for I card. So we go through each of our cards one by one, our numbered cards. So starting with card 1, well, I equals 0 essentially. And we see how many matches we've got. Multiply by the number of card 1s we have, which is 1 to begin with. And that's how many... Okay, so let's write this out. So, right, num. So we're gonna go for each of the next, so for k in range num matches. So we want num cards I plus 1 plus k plus equal. So it's going to be cards I times, so it's going to be the number of card I's we have. But we wouldn't. Oh, it's just that, isn't it? How does the rule work again? You win 1 copy of each of the next num matching cards. Okay, so it's that. Because you win 1 for each card eye you have. I haven't used card. This is matches. Yeah. Is that it? And now print num cards. Let's have a look at what it looks like. What? Okay, num cards hasn't changed. Oh, num match. What the? Okay, so I'm not using. I'm using the wrong variables here. This is matches. No. This is num cards. Oh, using the wrong. We're doing them the wrong way around. Okay, try now. 1, 2, 4, 8, 16, 32, 64. It's exactly double. That's not right. Is it? Oh, wait. No, it's not exactly doubling. Okay, that is about right. So that's 10, 10, 10. So yes, they will start doubling because the first 10 are always contributing. And then it sort of, at some point it stops, it seems. It didn't have to, but because of the numbers it stops. I guess that's because it gets a few zeros. And then it kind of just does that sequence. It always starts doubling, but that's correct. Alright. We just want the total number of cards. Correct. Yeah. I found this one easier than yesterday's, actually. Well, yesterday's conceptually was easy, but you always have to... It's always tricky to write 2D grid stuff. But this one was a one-dimensional array, and it can be done in an iterative order. And the only real catch, like the only real pitfall, would be if you were to do each copy of a card one by one. But the example they gave you basically gives it away. They kind of hint that you should do them in batches. I mean, I can try doing them one by one, so let's see if it's too slow. So, what would I do? I would just say... So you would do 4... So for each copy of this card, we do this whole process. Just add 1. So it just adds an extra factor. Yeah, it still completes, just It just takes like 1 more second, so... Okay, I don't think there's really any major pitfall then. Just a nice 1D array. I don't think it was hard. I think this was the easiest problem we've had this year. Easiest when you take into account both the parsing and the algorithm. I think, for example, question 2, day 2, had the easiest algorithm, but the parsing just slightly more effort required, because in 4 that's pretty nice. As long as you Python string.split on spaces, you've got it. No more parsing than that. Oh, and I just realized the vertical line isn't in exactly the same place every time. I thought it might be in variable places. So, but still, it's good to write your program according to the specification, because the specification didn't say there were like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers exactly, even though that's probably how scratch cards work. I mean, there's probably always the same number of numbers, but I think it's always good to check where the vertical line is. Okay, well that's today's problem. Let's check the old leaderboard. Cool. Today, fastest was 1 minute 22. I feel like that's the fastest any day has been done so far, and that's believable because yeah, it's just very straightforward problem. But that was a whole 1.5 minutes faster than second place, so this anonymous user 446043 did pretty well. 43 seconds. Alright, let's have a look at stats. Ooh, approaching 200,000 people for problem 1. It's a popular year. Because look, last year's is still sitting at... How do we even do this? 278,000, and that's accumulated over the entire year, so... Alright then. Looks like we're building islands. So this was the snow island, and now this is the island. This is I quite like this theme. Only 12 finished last year. 12k finished. Well, it's we can't really tell from the stats because that's just how many people did that specific problem. But I don't know if there's a stat which tells you how many did the entire year. So yeah, 12k finished that specific problem there. But day 25 is only part 1, so... Oh, it was the snafu problem, yeah, I remember that one. But yeah, of those 12,000, there may have been some problems they didn't do because there were harder problems than that. Yeah, I don't know if he should add some stats here just to say how many completed the entire board. That's a pretty nice stat. Of course, part 2 is to solve... Yeah, no, you were right, actually. 12,970 people solved all 25 problems, yeah. Because part 2, the gold, the second star, is to solve all the previous problems. Yeah. So that's actually quite high then, because it's not much less than 15168, which is how many people solved 22. So you'd have thought it would be much lower than the lowest of the previous days, because they'd have to solve all the other problems as well. But that just goes to show that a lot of people were committed to finishing the lot. Yeah. So yeah, that is how many people. Okay, so that is the stat. So yeah, that breaks it down then. 7,000 people solved the final question, but didn't solve all the previous problems. But yeah, quite a high proportion stuck through to the end. And alright, the other stat we'd like to know is how many people participated altogether, because it's not necessarily 278,000. Some people might have dropped in later. I don't know. It's probably around 300,000. Okay. Is Amaro doing his solution by any chance? Let's have a look at Twitch. Or anyone doing Advent of Code. No. Well, I don't really have enough viewers for rated anyway. Alright, we'll leave it. Okay, so that was nice and quick. I think I did it in like 20 to 25 minutes. Alright, well, see you tomorrow for day 5 then. I think after day 5 is where, well, I would say after day 5 is where things start getting tricky, but clearly it's already been a bit tricky. People have found the first few days. Actually, some people believe that it was done on purpose this year, much harder than before, because a lot of people are using ChatGPT, despite the rule that has been introduced this year that you're not allowed to use ChatGPT. But you know, clearly some people feel compelled to cheat and reach the top of the leaderboard. So I think he's tried to make his problems harder to parse, and maybe the language harder for a language model to work out. I don't know, because the algorithms are not too hard, but it seems to be the parsing and the interpretation that's tripping people up. So that would indicate maybe it's an anti-ChatGPT measure. But how effective it is, I don't know. I think ChatGPT will still manage. It's not much you can do. Alright. Okay then. We'll see you tomorrow. Bye.